In this video, we're going to take a look at an example of attempting to look around a corner using a mirror and try to figure out how much of a painting we can see using this mirror. Okay, so here's our basic setup. We have U, this is our kind of universal symbol for an observer. It's supposed to look kind of like an eye. There you go. That's the easiest way to remember what this symbol is. It's our universal symbol for an observer. So you can imagine you are standing here. You are looking at a mirror, which is on a wall over here, and you're trying to see the painting on the other side. And we just have a wall blocking you, so you can't look straight at the painting here. Okay, so the question that we want to answer here is, how much of this painting can you see using the mirror? Can you see all of it? Can you see just a small fraction of it? What of the painting can you see? Now, our restriction is that in order to be able to see a part of the painting, there must be light that can come from the painting, bounce off the mirror, and then hit your eye. Okay, so let's just try one part of the painting and see if that works. So let's try the very bottom of the painting here. Okay, well, if light leaves from the bottom of the painting, and let's say it hits the mirror at this location here, well, that light has to bounce back off at the same angle, which means that light from the bottom of the painting, which hits the mirror here, is going to end up hitting the wall and not your eye. Okay, so you certainly cannot see this light ray because it didn't go into your eye. All right, well, let's try again. What if we took light and we had it hit the very bottom of the mirror? Well, it's going to bounce off at the same angle as it came in at, and it still is going to miss hitting your eye. And we could try this for any other angle. So we could have light that goes from the bottom of the painting, hits the mirror, and then goes straight back to the painting. But there's no way for light to leave the painting, hit the mirror, and then get to your eye. So we can conclude that we cannot see the very bottom of the painting. All right, so now let's erase this attempt and think about, well, I could continue to do this same procedure, moving up the painting slightly over and over and over again until I got to a point where I actually had a line that was able to bounce off the mirror and hit my eye. But it's actually a little easier to work backwards and say, okay, let's trace a line from my eye off the mirror to the painting and see what the closest spot on the painting is that we can see. So if I draw a line from my eye straight to the bottom of the mirror, and then that light bounces off the mirror at exactly the same angle. So this angle and this angle are the same. These two angles are the same. I get my light hitting the mirror here, and I'll just mark this with blue. So that location right there is the closest spot on the painting, the lowest down spot on the painting, that I am able to see. Any other light that I draw, so I'll draw like some blue light here, just to make an example of it. So imagine that I have light that doesn't hit the bottom of the mirror, it hits somewhere in the middle of the mirror. Well, now if I do this, say it hits the middle of the mirror, that light has to bounce off at, again, the same angle that it came in at. It's going to come here on the painting, right? So light that bounces from the painting off the middle of the mirror is going to come from higher up off of the mirror if it wants to reach my eye, right? And so what we're going to end up having is that the lowest, in this picture, point of the painting that I can see is going to be the light that comes from the painting, bounces off the lowest part of the mirror, and then enters my eye. Okay. And now let's do our highest point on the mirror that we could hit. So if light comes from the painting, hits the highest point on the mirror, and then enters our eye, let's see where that light comes from. All right, so we're going to do the same thing. We're doing this backwards just because it's a little easier to do geometrically. To start with our eye, draw a line, it hits the very top of the mirror, bounces off at the same angle that it came in at, and hits the painting here, which means that light that comes from the painting this way bounces off the very top of the mirror and reaches our eye. So we can see all of the painting in this region here, but outside of that region, any light that comes through the mirror will miss our eye. Just like we showed with this region, the same thing can be shown for regions above. And this is the part of the painting that we can actually see. Now let's try to do some actual mathematics on this problem and figure out what section of the painting we are actually able to see in the mirror. So the question is basically, how long is the segment of the painting that we can actually see? So in our last image, we found that there was some minimum location on the painting that we could see and some maximum location, and we're going to try to find those two locations and then the difference between them to see how much of the painting we can actually see. Okay, in order to do this, we needed some distances. So let's assume that you are standing 3 meters from the wall, that the mirror is 3 meters up the wall from you, and that the mirror is itself 2 meters long. And that the painting is at the same level as you. So it is also 3 meters from the wall that this mirror is on. Okay, so let's figure out how we can use that information to try to find the location of the kind of lowest spot and highest spot on the painting that we can see. All right, just to give us a reference, I'm going to create an axis here. We really only care about the y-axis, so I'm going to call this 0, and then we'll have the positive y-axis moving up. I guess I should move this a little bit here. I want your location to be the 0 of the y-axis. So this is y equals 0. Okay, so now let's do our same technique of drawing a ray from the eye to the painting. And we'll do this at the lowest possible point. So we'll draw a ray from our eye off the mirror to the painting, where again, we make these two angles the same. And this will give us the lowest point on the painting that we can see. And we again think of the light as coming from the mirror to our eye. It's just easiest to draw our ray from our eye the other way. All right, so this is an arrow here. Okay, well, we actually have enough information to find this angle here based on our 3 meters and 3 meters. So the idea is that we have the ray, we have 3 meters, 3 meters, and then our angles are always measured from the normal, so the normal comes here. So we're really interested in this angle here, theta. But due to the symmetry of the system, we know that these two angles, these two thetas, must be the same. And because the two sides of our triangle are 3 meters and 3 meters, we know that this must actually be 45 degrees. So we could do like an arctangent to figure this out, but we can just visually see here that theta must be 45 degrees. Okay, well, then we know that our light leaves at the same angle. I didn't draw that very well. Let me retry. We know that our light leaves at the same angle, theta, and then it strikes the painting. So I'll again make the painting red here. So then it's going to strike the painting at some location. And what we're interested in is the height here. So the distance between our y equals 0 point and the location where the light actually strikes the painting, or where the light from the painting leaves the painting to get to our eye. Okay, well, this is actually going to be pretty straightforward. So we know that this is 3 meters, and due to the symmetry of this triangle, this must also be 3 meters. So this point here is going to be 6 meters above us. 3 meters plus 3 meters. All right, so the lowest point that we can see on the painting is 6 meters away from our eye in the y direction. All right, that worked out pretty well. Now, let's try to do the same thing. I'll do it in blue, just so we can keep things straight. I'm gonna erase this here. This one's gonna take just a little bit more trig, but it's still not gonna be so bad. All right, so now let's draw a line from our eye that strikes the very top of the mirror, bounces off at exactly the same angle, and hits. So we're interested in finding the height of this point here, where the light really leaves the mirror, or leaves the painting, strikes the mirror, and comes back into our eye. So I'll again draw the arrow to say light is coming this way into our eye from the painting, and we want to find this location. So now we can do the exact same thing where we try to draw this triangle. So again, we can draw this blue dotted line here. We know that it's going to create a triangle that has a base of 3 meters and a side of 5 meters. And that we are going to bounce off the wall and create another triangle which has a base of 3 meters and a height of 5 meters. And what we're looking for is the height of the top of this triangle. And so I realize that my triangles don't look the same. They should be the same. They should be exactly the same, these two triangles. Sorry for my artistic failure there. But we can see that our y distance total here is 10 meters, which means that the topmost part of the painting that we can see is 10 meters away from us. And light here follows this blue path in order to reach our eye. And all of the sections in between these 2 points have light would come from that section, hit the mirror at some location, and then reach our eye there. And any sections of the mirror outside of this box here, or this length here, will not be able to be seen by our eye because there is no path for the light to bounce off of the mirror and get to our eye. As a final note, I just want to talk about how you would actually see this painting. And remember that your eye always interprets light as following a straight line path, which means that your eye sees light coming in along this black line here, and it says, oh, that light must have followed a straight path and therefore come from over here. Likewise, the light that is coming in along this blue line, your eye says, oh, it must have followed a straight line path and come in from over here. So your eye would actually see this section of the reflected painting here, and your eye would not be able to see any other parts of the painting itself. You would interpret it as being just like a normal mirror. The image is virtual on the other side of the mirror.